So I will first start with introducing a few concepts about endocrine disrupting chemicals. First, what are they? They are natural or man-made chemicals that can mimic or block or interfere with hormones in the body's endocrine system. Where do we find them? We find them in our food with pesticides, with plasticizers, which wraps our food. We find them in our environment because they were leaked by the industry. We find them at home also in our cosmetics. We find them in our cleaning products or in flame retardants in our computers and so on. And then they are used also in medical care with transfusion pouches, catheters, and so on. So we're all exposed to endocrine disrupting chemicals, several dozens of them actually. You're going to hear later, it's considered that a fetus before being born has seen already more than 100 EDCs. It continues on during childhood. And what you can see here is actually a summary of 6 different European studies covering several thousands of children. And what we can conclude from that is that for the majority of those endocrine disrupting chemicals, 90% of the European children are exposed to them. It is actually difficult, I should say impossible, to find control population which are not exposed. And among them, we find plasticizers and pesticides mostly when we talk about children. We are all exposed to endocrine disrupting chemicals throughout life. The title of this joint meeting we just had was Endocrinology Across Life course. And sadly enough, EDCs are actually an illustration of the importance of endocrinology across life course. Some of them are considered non-persistent. That's the case for plasticizers, such as bisphenols or phthalates, parabens. We're exposed to them every day. So 90%, more than 90% of the European population is positive for BPA on any given day. And others are persistent. That's the case for flame retardant or PCBs, for instance, and they accumulate in adipose tissue and remain for years in our organism. And as it was just nicely introduced, the fetus and the child, because they depend on hormones for the establishment of those circuits, which are very important for later function, cognitive function, reproduction, energy balance, they're also very sensitive to very low doses of endocrine disrupting chemicals with health effect during the whole life. So what we heard during the meeting is that exposure, gestational exposure to phthalates, for instance, in boys is associated with lower birth weight. We also heard that endocrine disrupting chemicals can alter the thyroid function. We're going to talk a little more about that. It has impact of IQ and ADHD in children. It is also associated with abnormal puberty and fertility impairment, both in men and women. It is associated with increased risk of obesity, metabolic syndrome, diabetes, and it increases the risk of some cancers. And we can consider that the impact of EDC on public health in the EU cost more than 150 billion euros per year in the EU. That was 10 years ago, so it's probably much more. And you can see that the leading causes that were identified based on the literature were obesity and neurodevelopmental disorders, with plasticizers, pesticides, and flame retardant being identified as the most common culprits. And maybe one other important concept also is the concept of the transgenerational effects of endocrine disruptors that was mentioned also in the introduction. So we know that DNA is more than just a sequence of amino acids. It has actually a 3D organization, a 3D structures. It is modified by chemical modifications such as methylation, for instance. And this organization can be transmitted from one generation to the other. And we know now that endocrine disruptors can have epigenetic effect and affect the 3D organization of DNA. So what does that mean? Well, that means that a pregnant mother is exposed to those several dozens of endocrine disruptors, the fetus is directly exposed, and the germ cells in the fetus are exposed as well. That means the parent, the child, the grandchild are directly exposed to those endocrine disruptors. But then the great-grandchild will be exposed through those epigenetic effects. That means that if we withdraw a compound from the environment or if we restrict its use, we have already lost 4 generations. So this meeting was actually the occasion to summarize some of the research that was produced within the Orion cluster. That's a cluster of 8 European projects funded by the EU, 50 million euros, and aiming at identifying and developing better screening methods because we do need them. One of the observations of that cluster was that the classical methods that are used now for screening for endocrine disruptors, ideally before putting the products on the markets, are not adapted. And we can use the bisphenol A as an illustration of this. So using classical methods, I mean, bisphenol A is considered to be an estrogenic compound. So using the classical method, you look at the weight of the ovary and you conclude that below a dose of 300,000 microgram per kilogram per day, there is no effect. You divide that roughly by 100,000 and you come to a dose that should be safe of around 3 microgram per kilogram per day. But then we have effect, and that's shown by research data, effect with much, much lower doses on the brain, for instance. We have effect also of replacement compounds such as bisphenol S. And so the EFSA actually lowered this recommended dose, much, much lower, actually lower than current exposure in Europe. And then this also led finally to the restriction of the use of bisphenol A by EU in consumer products. So just to illustrate the research that was presented at the meeting, I would like to focus on the thyroid and brain development. You're going to hear about the brain development later this morning. The brain development relies on some very important steps for its development. Progenitor proliferation, then those progenitors will actually slowly migrate and differentiate. They will establish connection between each other, and they also rely on the development of another cell that is called the glial cells, which are really the ultrastructure of the brain. And those events actually strongly depend on thyroid development, of thyroid function for their establishment. And I would like to illustrate this with a thought-provoking observation, which is the end of the Flynn effect. So what has been reported again and again in the US and in Europe is this constant increase in IQ for kids until 1975, kids born until 1975. And then what has been recorded again and again also is this constant decrease. It's been documented in Europe, it's been documented in the US, this decrease in IQ since the 70s. Of course, it's multifactorial, but because we know that EDC alter brain development, we can wonder, of course, about the impact on IQ. And that's what we've heard during this meeting. So epidemiological data showed that prenatal exposure to some ubiquitous EDCs is associated with lower IQ, with impaired learning and memory. And again, you're going to hear about that. And then laboratory data shows that EDCs alter the establishment of neuronal connections, which are crucial for learning and memory. And when you look at those epidemiological data showing that the kids who are the most exposed lose about 5 IQ points, you can wonder about this impact. And that's illustrated here. So you can see a shift of the whole population by 5 IQ points. What does that mean? That means we lose some gifted people, but we also have a twofold increase in kids with learning difficulties and a more than twofold increase also with patients showing intellectual disability. So the impact on the population is actually huge. And what we heard during the meeting is that some of those effects are associated with exposure to thyroid hormone disruptors, and the classical methods focus on the size of the thyroid, basically, to decide if a compound is a thyroid hormone disruptors. But then Joseph Curley actually explained that there are much more targets when we look at the thyroid hormone systems, because the hypothalamus and the thyroid regulate the way the thyroid will produce thyroid hormones. EDCs can also affect the way they're transported to the target organs, the way they are metabolized, the way they act on their receptors, the way they are activated, or their action within the cells. And so within the Athena project, the European project, they actually screen several thousands of chemicals, because that's also something we're facing, basically exposure to thousands of chemicals, looking at those different targets along the thyroid hormone axis. So I would like to conclude with the EU three-pillar approach to EDCs, which is first minimizing exposure to EDCs. And we can say that we've heard enough data again to say that there is a need to minimize exposure to EDCs. We cannot only rely on individual measure, we need regulations. Stimulate research to guide decisions. We've heard about those EU-funded projects. There is still a need for research exploring transgenerational effects of endocrine disrupting chemicals, looking into mixture effects, and then foster stakeholder dialogue and collaboration, and that's what we're doing today. There is some progress in terms of regulation. There are also some concerns. There is a classification, packaging, and labeling regulation of chemicals, and that's a real progress. It contains a definition of what is an endocrine disrupting chemicals. Then the REACH regulation of chemicals is actually key for the European Green Deal. It's been delayed, and that's a real reason for concern for scientists and clinicians. And then in 2020, the European Parliament actually passed a resolution aiming at banning EDCs, but unfortunately it's been stalled. So that's also a reason for concern. And with this, I would like to thank you for your attention.